All right, this video is over 6-7D. Generate equivalent expressions using operations, the inverse identity, commutative, associative, and distributive properties. The most important one on this is going to be the distributive property. The students have done all of the others. They might not have realized that there was a name to them, but the distributive property is going to be the newest one and the one that is the hardest for them to wrap their minds around. All right, so what that means for them is they have to create equivalent expressions using such properties as the ones that I listed before. And once again, the distributive property is going to be the trickiest one for them. Next, I would go into the key vocabulary. And I would just read over this with them and discuss what it means. So the distributive, multiplying the sum of a number gives the same result as multiplying each add-in by the number and then adding the products together. There's a lot of vocabulary in that definition. So I would ask them, what does the word sum mean? And of course they would tell you that that's an addition problem. Okay, well, it gives the same result as multiplying each add-in. What's an add-in? And they would need to tell you that an add-in is one of the digits that's being added to another. Okay, and then by adding the products, well, what does products mean? Products would be multiplication. Okay, so they can kind of see where this is coming from. Commutative says you can swap numbers around and still get the same answer when you add or when you multiply. And I would give them an example of this commutative property. So we could say something really simple. So 1 plus 3 is the same thing as 3 plus 1. And normally when you show them something simple like that, they really understand and they really grasp the concept. All right, then we have the inverse. Adding by a number's opposite or multiplying by a number's reciprocal. Okay, so adding by a number's opposite. So 1 plus negative 1, and you get 0. Or multiplying a number by its reciprocal. So if I wanted to say 2 times its reciprocal would be flipped, so 1/2, that's just going to give me 1. So the additive inverse is always going to equal 0. The multiplicative inverse is always going to equal 1. All right, then you have the identity. States that the product of 1 and any number is that given number. Also states that when you add a number to 0, your solution is that given number. So the identity property for addition is if I took 3 and added 0 to it, I would still be left with 3. The additive property for multiplication states that if I multiply any number times 1, I'm going to get that number. And then we have the associative property. When adding or multiplying 3 or more real numbers, the sum is always the same regardless of their grouping. So that's telling them that they can multiply, they can move the parentheses around however they want, and they're still going to get the same answer. Okay, now we do have a more in-depth notes page. This is just vaguely going over everything. All right, we're going to move on to this next page and just see if the kids can match. And at this point, I would actually have them come to the board and see if they can draw a line to the correct property. Okay, so each student would come to the board and draw a line. Now, I'm just guessing that the distributive property is going to be the one that they do last because they're not really sure about that one yet. And we haven't gone into any great discussion or description of the distributive property. So they should be able to do them all, and then in the end, they'll figure out the distributive property. So here's our distributive property right here. And so I would take them back and I would look at that definition again. Multiplying a sum by a number gives the same result. Okay, multiplying a sum by a number. Well, here's a sum. Here's a sum, and you're multiplying it by a number. Okay, so that's what they're talking about there. Gives the same result as multiplying each add-in by the number and then adding the products together. So it gives the same result as multiplying and then adding. So the 20 right here came from 4 times 5, and the 24 came from 4 times 6. and they both equal the same thing. The left side and the right side are exactly the same, okay? Now there's a video on proportions, and they can match the equivalent expressions to their property name through the video as well. Normally I would put the video on Schoology and let the kids match it up there. That way they have control over the screen. The next thing that we would do, we're going to go to a different screen, is we would look at our notes. Now these notes are already filled in. The notes that I would give to the students would not be filled in. They would have to fill in the words. They would have to fill in the blank. So the commutative property, they need to remember the CO, the change order, and then I want them to come up with some examples. So they've seen the examples on the board, they've drawn lines, they've watched the video, and they've matched their own problems. So now on here, they should be able to come up with an example. All of these should be pretty easy for them until they get to the distributive property. They are going to struggle with it. So the distributive property is the one that we're going to focus on. And in fact, for the notes, I would go ahead and give them an example and write it down for them. That way they have a correct example for that. All right, let's go back to the flip chart. Okay. Let's answer the following questions together. Write an expression that is equivalent to 20n plus 15. Okay, so the first thing that I do here is I ask my students, are there any parentheses? And of course, they're going to tell me no. And then I ask them, okay, well, what's different about this problem than a regular addition problem? And this is where they're going to need that think time. They're going to need time to realize that, okay, wait a second, there's something different. She wants us to find something. And once you've given them that time, most of them will come to the realization that there's a variable attached to that 20. That means that this is a different problem than a regular addition problem. So what I've trained my students to do is if they see this and they see that there's a variable attached in there, that is almost certain the distributive property. So now they're going to have to work backwards and figure out what they can do to this problem in order to write an equivalent expression. Well, this is the second half of that distributive property. Only the addition is here. The multiplication is missing. So that means that I have to undo the multiplication to figure out what they did. So then I ask them, what do 20 and 15, what factor do they share? Hopefully they'll come up with 5. So then we say, okay, well, if I pull a 5 out and I have a 5 sitting here, what is 20 divided by 5? Well, 20 divided by 5 is 4, and the n just goes along for the ride. And 15 divided by 5 is 3. So now we have our distributive property, and the kids can recognize it and should be able to go back and forth. You should be able to give them either half of that problem, and they have to be able to go forwards and backwards. All right, now the next problem is going to ask them to use the associative property to generate equivalent expressions that can be used to find the total number of sandwiches. So they've already given them, okay, to find the total number, you could add the numbers together. So they've already given them that part. The only thing that they have to do is, since they're using the associative property, they're going to have to insert parentheses, and then they're going to have to mix it up and change those parentheses around. So there you see in the answers, and they could have them flopped either way. It doesn't matter. All right, on our next page, now these questions they would try with a partner. Okay, so now they're going to be working together and collaborating. Which of these properties do the equivalent expressions above illustrate? So now they have to recognize, okay, that's addition. The numbers and the variables are in the exact same position. Nothing has been moved around. The only thing that has changed is the parentheses. And that's the big thing that they're going to have to realize. I always tell my kids, you're going to have to put on your detective hat and you're going to have to figure out what is different from one side to the other. And they're usually pretty quick with the associative and the commutative. All right, the one on the bottom. Are these two expressions below equivalent? Explain. Okay, so when we look at these, we see that first of all, we can combine some like terms, okay? And since the two of these are different, I would go out on a limb and guess along with the kids that this is probably the distributive property. So I'm going to rewrite this as 12m plus 4. Okay, so now I need to see if I can turn 12m plus 4 into this down here. So I would ask the students, what do 12 and 4 have in common? Because if I'm going to multiply, I'm going to have to figure out what they divided by first. So I know that 2 can go into that, and 2 can go into 12, but 4 can as well, and that would give me a 4 on the outside. So 12 divided by 4 is 3, and that would be m plus 1. So it turns out that these two are not equivalent. In order for them to be equivalent, we would have to change some of those numbers around. All right, our next page, use the algebraic property named, generate equivalent expressions for the following. So now all it's asking them to do is just regurgitate that property and see if you can figure out what needs to be done. I think this is a great page for their notebook. I would print this page out and have them tape or glue it in. That way they have it right there along with the 3 column notes that we did so that they have plenty of examples, especially when they're going back and doing their homework, especially with that distributive property. It is going to come up a lot and they need to be really familiar with it. All right, then we have a Kahoot for them to do. Kahoot is great. They love getting out their cell phones or their laptops and working on the Kahoot. So then we could do a little independent practice with the Kahoot. And finally, to wrap up, a quick write at the end of class. A lot of times I have them do their quick writes on sticky notes, a little larger than the small square size, and then they can just slap them on the door as they walk out. So they need to explain how the properties can help us create equivalent expressions. How and why might these properties be useful in our everyday lives? Again, I think that they could pick any property. If this was an upper level class, I would probably steer them towards the distributive property and make them explain how that works. For maybe my SPED or my 504 classes or kiddos, I might steer them towards the commutative and the associative because I think that one's a little easier for them to put into words. And they've been doing that one longer, and it would be a little easier for them to explain. You might even pair up maybe your weaker kids with your stronger kids and have the kids have those conversations. Maybe have the stronger kids explain their answers to the weaker kids and get that dialogue going so that your struggling learners have the same opportunities to understand and visualize the material that your strong kids grasp rather quickly.